Hey, welcome to a new POPX tutorial. Today we're creating fields of flowers and grass driven by a circular ramp falloff that animates their growth into waves. Let's dive in. Overview. The network breaks down into 5 parts. First, the flower modeling network. We start with a pattern pop to build the outline of a single leaf. We copy and flip it, then merge the two halves to close the leaf shape. A skin pop turns that outline into a surface. A twist pop gives the leaf a subtle curl. Then a copy pop scatters 6 leaves around a circle to form the flower. Finally, we transform it to origin and rebuild the normals. Second, the grass network. Each grass blade starts as a line pop. A curve pop adds a curve U attribute, a normalized value from root to tip. A group pop marks the tip points, so we can place flowers on them later. A POPX instancer scatters the blade across a grid distribution. A POPX randomize varies the scale and color of each blade. Color comes from a ramp top, green to yellow to white to purple. A texture falloff drives the growth, fed by a circular ramp top with an animated phase. Where the falloff is 1, the grass grows tall. Where it's 0, it stays small. We unpack each instance into real geometry so we can deform it further. A noise pop adds per blade variation, locked to the rest attribute so it doesn't crawl over time. A mathmix pop adds the noise to position, multiplied by curve U, so only the tips move. Third, the grass tips. We grab the grass null and convert the line strips into points. A delete pop keeps only the tip points using the tip group. A random pop and a second delete pop thin those tips out so flowers don't land on every blade. The result is a point cloud, 1 anchor per flower. Fourth, the flowers. A second POPX instancer takes the flower geometry and distributes it onto the point cloud. We copy the falloff attribute over from the grass instancer so the flowers inherit the same wave. A POPX randomize varies their scale and color. A remap falloff inverts the wave for the flowers so they bloom in the opposite direction from the grass growth. A transform modifier scales them down where the inverted falloff is low. And finally, rendering. PBR materials for the grass and flowers with a camera and 2 colored lights with soft shadows. A bloom top adds glow. A luma blur driven by a circular ramp top softens the edges. An open color IO top runs a color filter mixed back over the original with a cross top. A level top boosts the brightness for the final image. Alright, let's get started. Hey, before we dive in, I want to show you popx.tools, the official POPX website. Here you'll find a getting started page with some basic examples. An installation guide. Comprehensive documentation for every operator. And a changelog for each version. Everything else lives on Patreon. That's where you get POPX itself, all the releases, the tutorials, and the project files. The links for the website and Patreon are in the description. Alright, let's get into building it. Flower modeling. Let's build the flower geometry. Drop in a pattern pop. We'll use it to create the first half of the leaf outline. Set the number of points to 4. We don't need much density, the flowers are small, and we'll copy a lot of them. On the type parameter, set X to a ramp from 0 to 1. Set Y to a constant of 0. Set Z to a sine wave. Set the number of cycles on the Z-axis to 0.5. On the map to high parameter for Z, set it to 0.15. This creates an arc on the XZ plane, 0 to 1 on X, 0 to 0.15 on Z. Drop in a transform pop, rotate 180 degrees on the X-axis. Merge the pattern and the transform together. This closes the two halves of the leaf outline. Connect the merge into a skin pop to create the surface. Drop in a twist pop after the skin. Set the operation to bend. Primary axis Y, secondary axis X. Strength -25, that gives the leaf a nice curl. Drop in a circle pop. We'll use it as the template points for the copy pop, 1 leaf per point to form the flower. Orientation ZX plane, division 6, so we get 6 leaves, uniform scale 0.8, and normal direction tangent, so each copied leaf rotates to face outward. Drop in a copy pop, connect the twist into the first input, that's our single leaf, and the circle into the template input. On the template page, toggle template rotate to vector on. This orients each leaf correctly, using the circle's normal attribute so every leaf faces outward from the center. The flower copies correctly, but it's flipped upside down. Drop in another transform pop after the copy. Rotate 180 degrees on the Z-axis. On the align page, set align translate X to origin. Align translate Y to origin from input set to minimum. This places the bottom of the flower exactly at Y0. Align translate Z to origin. Drop in a normal pop to rebuild the normals. Leave the parameters at default. Finish with a null, rename it flower. And that's the flower modeling network. Grass network. Now let's build the grass network. First, we need a render resolution to drive a few parameters down the line. Drop in a render top and set the resolution on its common page for our final render. Leave it on the side. Drop in a parameter chop. Reference the render top on the operator parameter. Toggle built-in on so it picks up the built-in parameters. Toggle custom off, we don't need it. Select resolution W. And resolution H. Now we have our render resolution available as channels. Drop in a speed chop. Set the speed parameter to 0.3. On the common page, rename the channel to phase. This will drive the ramp top phase for the falloff later on. Now to the grass. Drop in a line pop. On the points page, set the second point so the line goes from 0 to 1 on the Y-axis. Our grass blade is now a vertical line. On the divisions page, set divisions to 4. We don't want a lot of points per blade, it'd be heavy. You can increase it later if you want more detail. Connect the line into a curve pop. We'll use it to create a curve view attribute, a normalized falloff from root to tip. On the lookup page, toggle apply lookup on. Set the lookup index attribute to dimu0, the built-in attribute on any pop geometry. Set the output attribute scope to curve view. Connect the curve into a group pop. We want to mark the tip point so we can place flowers on it later. Name the group tip. On the attribute page, select the curve view attribute. Set the function to equal to. Set the value to 1. The last point of the line is now in the tip group. Connect the group into an instancer. On the distribution page, the type is already grid. Open the settings. Set grid X to 512. Grid Y to 1. Grid Z to 512. That's a lot of blades. Reduce if your GPU complains. Rotate the line strips 90 degrees on the x-axis, so they point outward, facing the positive Z. For the grid size, we want to match the render resolution ratio. Reference the parameter chops resolution W onto size X divided by resolution H, so the grid keeps the same aspect ratio as our render. Drop in a randomize after the instancer. We want random scaling and random color per blade. On the scale page, toggle randomize uniform scale on. Set min to 0.005. Max to 0.02. Set scale mode to replace. On the color page, toggle randomize color on, then toggle color ramp on. We'll use a custom color top. Drop in a ramp top. On the common page, bump up the resolution. Set the pixel format to 32-bit float RGBA. Set the ramp colors, green, yellow, white, and purple. You can also just copy the ramp from the example file. Connect a level top after the ramp to boost the colors a bit. End with a null top. Name it color, then reference that null as the custom color top on the randomize. Quick tip, on the common page of any operator, you can toggle render primitives off once you're done setting it up. The randomize doesn't need to keep rendering, which saves GPU and CPU. Toggle it back on whenever you want to see the result or tweak the values. Now the circular falloff. Connect the randomize into a texture falloff. Drop in a new ramp top. Flip the colors from black to white to black. Set the type to circular. Reference the speed chop's phase channel onto the ramp's phase parameter. Set period to 0.2. Set extend left to mirror. Set interpolation notch to ease in and ease out. On the common page, reference the parameter chops resolution channels for the ramp resolution. Set pixel format to 32-bit float mono, no colors needed for a falloff. Connect the ramp top into the second input of the texture falloff. The texture input its samples. On the falloff page, toggle preview falloff on to verify the circular wave. Then toggle render primitives off on the common page and turn preview falloff back off. Connect the texture falloff into a transform modifier. It uses the falloff attribute by default. Set uniform scale to 7. Now the grass grows where the falloff is 1 and stays small where it's 0. Toggle render primitives off on the common page. Now we want to add per blade noise, but noise on instances would affect each instance as a whole, not the individual line strip points. Drop in an unpack to convert the instances into actual geometry. On the unpack parameters, set transfer attribute to star. This copies all our colors and falloff attributes onto the unpacked geometry. Drop in a noise pop after the unpack. Set the noise lookup attribute to rest. The instancer creates this rest attribute as the rest position. Using it keeps the noise seed stable as the grass moves, otherwise the noise would crawl. Set period to 0.001. Amplitude to 0.0125. Exponent to 0.75. On the transform page, on the translate 4D parameter, type the expression abs_time.seconds multiplied by 0.05. This animates the noise smoothly over time. On the output attribute page, set combine operation to none. We don't want to apply the noise to position yet, we just want to generate the noise attribute. Toggle the noise toggle on. Now the noise attribute exists on every point. Drop in a math mix pop. It lets us do math on attributes. On the combine page, set the operation to A plus B times C. Scope A is P, our position. Scope B is the curve view attribute. Scope C is the noise attribute. The result automatically goes back to P. Because noise is multiplied by curve view before being added to position, the tips of the grass move much more than the roots. Cap it with a null pop. Name it grass. And that's the grass network. Grass tips. Now to the grass tips network. Drop in a select pop. Reference the grass null on the pop parameter. This lets us work on the grass geometry in a different location, like copying it. Connect a convert pop. We want to turn the line strips into just points. On the convert menu, select keep points and delete primitives. Connect the convert into a delete pop. We're going to keep only the tip points. On the delete page, change the operation to keep selected instead of the default delete selected. On the group page, select the tip group we created earlier. Now we want to thin out the tips because we don't want a flower on every single blade. Connect a random pop. Set random size to 1. We just want to float random attribute. Set combine operation to set. On the output attribute scope, name the attribute rand. Connect the random into another delete pop. On the attribute page, select the rand attribute. Leave the function at its default and set the value to around 0.9. Tweak it up or down for more or fewer flowers. Cap it with a null pop. Name it point cloud. And that's the grass tips network. Flowers network. Now to the flowers network. Drop in an instancer. Connect the flower null geometry into it. On the uniform scale, type 0.01. We'll replace this with the randomize later, but for now, we want to see the distribution. Rotate the flowers 90 degrees on the x-axis so they face the positive z direction. On the distribution page, set the type to point cloud. Reference the point cloud null from the tips network on the template object parameter. This copies the flowers onto our tips. Toggle copy template attributes on. It auto-selects the falloff attribute. Leave it as is. The flowers will inherit the same wave as the grass. Connect a randomize after the instancer. Toggle do falloff off. We don't want the falloff to drive the random scale yet. On the scale page, toggle randomize uniform scale on. Set mine to 0.001. Max to 0.015. Set scale mode to replace. On the color page, toggle randomize color on. Toggle color ramp on. We'll use a custom ramp top. Drop in a ramp top. You can copy the colors from the example file, bump up the resolution, and set the pixel format to 32-bit float RGBA. Drop a null top after the ramp. Name it color. Reference that null on the custom color top parameter of the randomize. On the common page, toggle render primitives off. Connect the randomize into a remap falloff. We want to invert the falloff so the flowers bloom in the opposite direction from the grass growth. On the falloff page, toggle preview falloff on. You can now see the circular ramp falloff applied to the flowers. Go back to the remap page and toggle invert on. The gradient is now flipped. Toggle preview falloff back off, and on the common page, toggle render primitives off. Drop in a transform modifier. Set uniform scale to 0. Do falloff is already toggled on, using the inverted falloff attribute. The flowers now scale based on the falloff. On the common page, toggle render primitives off. Connect a POPX geometry comp for the flowers. We need this one specifically, not a regular geometry comp, because the flowers are still a packed POPX geometry, not a regular pop geometry. A standard geometry comp won't work here. While we're here, drop a geometry comp for the grass too. That one's the standard comp, since we already unpacked the grass into actual geometry earlier. Connect the grass null into it. And that's the flowers network. Next is rendering. By the way, if you don't want to build the network from scratch, you can grab the project file from Patreon, along with the project file for every tutorial I made. The link's in the description. Alright, back to building. Rendering. And finally, the rendering network. We already dropped a render top at the beginning and set its resolution. Now we're going to render through it. First, let's set up the layout so we can see the render. We'll split the network panel into 2 panes. Right-click on the path bar of the TouchDesigner UI where it says Project 1 or whatever your project container is named. Click Parameters. On the layout page, reference the render top's resolution W onto width and resolution H onto height. While you're still in the parameters, go to the look page. Make sure the background top is referencing the out operator. This way, when we connect the render to an out top in a moment, it'll show up as the panel container's background. Then close the parameters window. On the render top, change the pixel format to 16-bit float. This gives us more color information. Now split your network panel into two, left and right. On the right pane, select a panel so we can see our project container. Drop in a camera comp. Drop an out top and connect the render top into it. Now we can see our render on the right panel. On the camera, set Translate Z to 2.2. Go to the pre-transform page, toggle Apply Pre-Transform on. Set Translate Y to 0.32. Translate Z to -0.5. Rotate X to 36. This aligns the grass grid nicely. Tweak it to your taste. Now lights and shadows. I'm going to copy the two lights from the example file and walk through their setups. On both lights, on the shadows page, soft shadow is enabled, filter samples and search steps are bumped up, light size is 0.1, and shadow resolution is increased. On the first light, the dimmer is bumped up a bit. The position is up to you to tweak. On the second light, the color is set to pink. Now the materials. I'm going to copy two PBR materials from the example file and walk through their parameters. Drag the first PBR onto the grass GeoComps material parameter on the render page. On this first PBR, the grass material, the base color is set to 3, 3, 3, like white, but stronger. Metallic is 0.071. On its common page, the wireframe parameter is set to topology wireframe, and line width is 2. This makes the grass look a bit thicker. On the second Geometries Instances page, reference the second PBR for the flowers. Same base color, 3, 3, 3. Metallic is 0 for this one. We can see the shadows now, but let's add some post-processing. Drop in a bloom top after the render top. Set pre-black level to around 0.5. Set bloom fill to around 6, tweak to taste. Next, we want a slight blurriness on the edges, driven by a circular ramp. Drop in a ramp top, connected from the bloom on a separate wire, not in between the bloom and the out. On the ramp top's output page, set Combine with Input to set resolution only. The ramp only takes the resolution from the bloom. Back on the ramp page, flip the colors from white to black, set type to circular, extent left set to black. This creates a circular gradient, white in the center, fading to black at the edges. Drop in a Luma blur, connect the bloom to the first input and the ramp top to the second. Reconnect the Luma blur into the out top. Set white filter width to 0, set black filter width to around 7. The edges now get a slight blur driven by the ramp. Next, a LUT for color grading. We'll use an Open Color I/O top. Drop in an Open Color I/O top. Connect the Luma blur into it on a separate wire. On the File Transform page, toggle Use File Transform on. Set the file source to a lot file. There's a free one attached to the project file. We don't want the lot applied 100%. Drop in a crosstalk. Connect the Luma blur into the first input and the Open Color I/O top into the second. Set the cross parameter to around 0.25. This applies the lot subtly. Finally, drop in a level top. Pump the brightness to 1.5. And that's the rendering network. Our Flower Waves project is complete. Thanks for watching, and huge thanks for the support. That's what keeps POPX evolving and the community growing. Come hang out on our Discord to ask questions, share ideas, or just chat with other creators. The links to the project file and Discord are in the description. See you in the next one.